sorting and the time complexity of each and every sorting is how the one sorting is better than the other one. Then finally we'll see the next half of the unit is searching. There are different types of searching, linear search, binary search, so sequence search is there. So different types of searching we are going to see. So first we'll start with the we'll see the topic sorting. So as we all know about sorting is a kind of technique. We are going to order the elements in some manner. Okay, a sorting algorithm is defined as an algorithm that puts the elements of a list in a certain order, which can be either numerical order, lexicographical order, or any user defined order. So it can be any type of sorting we can do. Either I want to do in a chronological order, or if I want to be, I will decide, the user will define, I want to define in this way only. Whoever coming the first, I have to sort in that manner. So sorting can be any type. Okay, either it can be numerical or lexicographical, or alphabetical, chronological, or we can use several names. Okay, in sorting, what are the different types? Okay, internal sorting, external sorting. So what actually is internal sorting? Which deals with sorting the data stored in the computer memory. Okay, in the computer memory here, it is referring the RAM, main memory. External sorting, which deals with the sorting the data stored in files. External sorting is applied when there is a voluminous data that cannot be stored in the memory. Okay, for example, I want to analyze large amount of data, huge amount of data in terms of TB. Okay, in terms of gigabyte, if it is the data is like that, so how will I sort? That kind of sorting is called external sorting. We will see in our syllabus, most of the sorting will be internal sorting. So what is, before getting into sorting, what is sort key? We have to know data records can be sorted based on the property. Okay, based on some property. Here we are saying that alphabetical or numerical. Okay, such a component or property is called a sort key, based on which parameter we are going to sort. Okay, the sort can be in either an ascending or descending, depends upon the application. A sort key can be defined using two or more sort keys. Okay, based upon the keys, we can able to what we are going to sort the elements for a particular information. There can be more than one key. Here, why you are saying that two or more keys? Okay, for an employee record in an company, for an employee record in a company. Okay, for a particular employee, I can have more than one key. For example, the key is what, the employee ID. Okay, the employee ID is one key, as well as I can have another key for the particular record. For example, already there is an employee ID, I can have another key as the name of the employee. Okay, these are the two keys. That's what we are saying. For a particular record, we can have more than two keys, or more than two keys. In such case, the first key is called the primary sort key, where I say the employee ID is the primary key. Okay, the other keys other than what you are defining is called the secondary sort key. Okay, fine. So in this, we are saying, so we are telling about sorting. Okay, so what are the analysis we are going to do on the different types of sorting? You're going to see around the 10 sorting techniques. All the 10 sorting techniques will have its own advantage and disadvantage. Okay, so what are the practical consideration when we are applying that sorting in some application? What are the challenges you will face? What is the complexity? That is called the analysis of the sorting algorithm. So what are the things? Number of sort key comparison that will be performed. Okay, so how many sort keys we are taking, number of times the record in the list will be moved, in what way the number of records. Okay, if you want to sort some sort an list sort and list, how many times the particular number of records or particular record or more than one record or moved in within the array, that we will see. Then best case performance, worst case performance, and average case performance. So we have seen in the third unit what is best case performance, worst case performance, average case performance. Okay, worst case we used to say what, big O notation. Okay, big O notation. Then best case big omega. Okay, average case big theta. Okay, next stability. This is one of the uh, practical thing we have to consider when analyzing the sorting algorithm. Stability of the sorting algorithm, where stability means that equivalent elements or records retain the relative position even after sorting is done. Okay, for example, in a given array you have some number of elements. Okay, in particular array, some two elements or three elements will be in particular in order. Okay, before sorting some two three elements will be in particular order. For example, contiguous uh, allocation will be there, contiguously allocated. After sorting also, the set of elements will will be in the same position. Okay, there won't be any change in the index of the particular element in the or set of elements in the array. So before sorting some two three elements or set of elements will be in the array. After sorting also, those elements will be in the same position, that we used to say as a stability. So even after sorting the algorithm, the elements are retaining the stability. So these are the practical consideration we have to check when implementing the sorting algorithm in different types of application. So there are different types of sorting techniques: bubble sort, insertion sort, selection sort, merge sort, quick sort. There are different types of sorting techniques. Okay, first we will see the bubble sort. Bubble sort is a very simple method that sorts the array elements by repeatedly moving. This is one important word here. Repeatedly moving the largest element to the highest index position of the array segment. That will show in pictographically. Consecutive. So in bubble sort, what we are going to do, consecutive adjustment pairs of the elements in the array are compared with each other. Okay, so the contiguous elements next to next. Okay, zeroth index is compared with the next index, first index, and the first index is compared with the second index. So this is what consecutive adjacent elements or compared. Okay, if the element at the lower index is greater than the element at the higher index, the two elements are interchanged. So if it is lesser, the zeroth index is lesser than the first index. Okay, what we will do, we will swap the zeroth index as well as the first index. If it is the case, when it is the case that if you are doing the ascending order, so that we will see. This procedure of sorting is called bubble sorting because elements bubble to the top of the list. Why? What is the name? What is the reason why they are calling this sorting kind of technique as bubble sort? The bubbles will move upwards, right? You are going to sort in either in ascending or descending. Okay, the elements, for example, you are going to sort in ascending order. The highest element should be placed at the last index of the array. So that's why this highest element is bubbling, like something like it's going towards to some extreme end. That's why it's called the bubble. If the elements are to be sorted in descending order, then in first pass the smallest element is moved to the highest index, or vice versa. If it is going to do what, descending order, the smallest element will be placed at the highest index of the array. That's all. Vice versa, we are going to perform either two of the choices, either choice what, the ascending or descending. So this is an example I shown, a small example where we can get a clarity about this bubble sort. So initially this is the array given. This is an array given. It consists of some n elements. The n is nothing but 1, 2, 3, 4, 5. So you have 5 elements in an array. So what actually, how the bubble sort will work? The first pass, this is step. Okay, in a single pass there are several steps. In a single pass there are several steps. For example, you have what, 5 elements in this array. If it is 5 elements, you will perform what, 4 passes. Okay, and each pass will have several steps. Keep in mind, you have 5 elements. If it then 5 elements, you will perform 4 pass. Pass is nothing but you're performing some iteration. Okay, 4 iteration. Consider that is the 4 iteration. In the first iteration, you will do steps. These are the 5 steps. It can be any number of steps. For example, we have what, 5 elements in this array. So it is an unsorted one. So first element, what we are doing is the first pass. This is the pass number 1. Pass 1. So in this pass 1, what we will take the first element 5. We will check with this second index. 0th index check with the first index. If it is higher, if the 0th index is higher, what we will do, swap it. Okay, 0th and first index are swapped. So after swapping, what happens, 3 becomes the 0th in the 0th position and the 5 in the first position. And next step 2 is what? Step 2 is that compare with the first index with the second index. Okay, when you compare, what happens, second index is what, higher when compared to the previous index. So we don't do swapping, which is why we not do swapping. Okay, so in the step 3, so as it is in the step 2 will be no change, as is the order is 3, 5, 8 only. Okay, and step 3, what happens, the 8 is checked with the next index, next contiguous index. So this is what the bubble sort works. Okay, when what is the, you can look, you can get some idea that while doing this comparison, automatically the highest element will be placed in the last index of the array. See, when I compare, see from this we can I can understood that 8 is the highest element. So we are performing this. Once we are performing this, the automatically the highest element in the array will come to the highest index. Okay, so this is what, pass 1. Okay, this is the pass 1. Since we have n elements, how many elements you have? N elements. N is nothing but n equal to 5. So we will perform pass, number of passes is 4. Why? Because n minus 1. So in this presentation, I have shown only the single pass number 1. Okay, in pass number 1, you have several steps. That is nothing but you are comparing with the other consecutive elements. So we, among the 4 passes, I have done only I have completed only the first pass. Still 3 more passes are there. Still 3 more passes there. Next 3, then the pass number 2, what we will do? Pass number 2, it will check again. 3 is compared with, this is the resultant. So this is the resultant array of the first pass. Then this is the input for the second pass. This is the output of the first pass, and this is the input of the second pass. Okay, I will give to this this as input to the second pass, and again I will do skip on steps. I will do what I will do, 3 compared with the 5. Okay, yeah, when I'm comparing 3 is comparing with 5, okay, 5 is bigger, I don't swap. Then again check with the 5 with 4, what happens? It is uh, lowest element, so what I'll do, I'll swap it. Okay, in this way, when the in the pass 2, when the completion of the pass 2, what happens automatically, which is the largest element from here, it is 6 only, automatically 6 only, so it comes to the second highest index. Okay, second highest index, so automatically here it is showing 6, okay, leave it. Okay, so from the pass 2, what happens, the second highest index, second highest element will be placed in the second highest index. So from this, what we can come to know that for a given n elements, the number of passes is n minus 1. This you have to know. So these are things you have to know. For n elements, the number of passes is n minus 1, that is 4. In case of bubble sort, we are telling about the bubble sort. So for n minus 1, so 4. Okay, and one more thing, and when the number of passes, okay, when the pass number is increasing, automatically the steps also will decreases. Automatically steps also will decreases. Why? Because what, the right side rightmost element of the array will be automatically sorted when the number of passes increases. Why? Because when the end of the second pass, when the end of the second pass, what happens, 6 and 8 are, I'm telling about the end of the pass 2. At the end of the pass 2, automatically two elements will be sorted. So it is placed at the rightmost, it is placed at the rightmost uh, index, rightmost of the array. Okay, then I have to sort only this part. I can split this array into two parts. One is unsorted one, this is the unsorted one, this is sorted one. Okay, so when the number of passes is increasing, when it comes 3 passes, automatically the steps decreases. Why? Because it has only 3 elements in the array. Okay, when next if it goes for fourth pass, so the steps decreases because you have less number of elements in the unsorted array. Okay, these are the things you have to analyze. Like with this only, we are going to write the algorithm for this. Hope this is understood. So what is the technique here? The same thing I'm going to tell in the slide. The basic methodology of the working of bubble sort is given. See in pass number 1. See in pass number 1, A0 and A1 are compared, comma, then A1, nothing but this is index 1 in first index, 0th index. So index are compared. Okay, so A1 is compared with the A2. Like this is goes on in the first pass. At last what? Finally, and so on. Finally, n minus 2 is compared with the n minus 1. Yes, n minus 2 is compared with the n minus 2 is what here? This one. N minus 2 is this one. N minus 1 is what? This one. That's what it's saying. N minus, this is the fourth index. This is the third index. That's what n minus 2. 5 minus 2 is 3. Okay, that's what. So n minus 2 is compared with the a n minus 1. So pass 1 involves n minus 1 comparison. So first pass n minus 1 compare. That means 4 comparison. 4 steps will happen. I mean like for 5, if the input is 5. Okay, if the input is 5, what happens? So n minus 1 comparison will happen. Okay, in pass 2 what happens? What I told, automatically the, if we have to, no need to worry about the, in case of pass 2, I no need to worry about what, the last element. Okay, it isn't sorted, somewhat it is sorted. Okay, it is sorted. In pass 2, I have to worry about the this only. So what is the number of comparison in case of pass 2? N minus 2. Okay, in case of pass 1 it is n minus 1. In case of pass 2 it is n minus 2. Okay, so finally n minus 3. So in case of pass 2 what happens? Finally n minus 3 is compared with the a n minus 2. That's what we told. So this is n minus 3. Okay, n minus 3 and n minus 2. These are compared in case of pass 2. So like that it goes on. So pass 3, for example, having n elements. So at pass n minus 1, at pass n minus 1, how it is compared? So again you are comparing a naught and a one are compared, so that, so at last what happens in pass n minus 1, we will have what only these two elements have to be checked. Only these two elements have to be checked in case of what n minus 1 pass, last pass, because this is what, for example, I'm telling this is in sorted order. This is in sorted order. If you are doing some passes in this given input array, you are swapping. So the right side is sorted, the left side is unsorted, and the last pass I have to check only these two elements only. That's what they are saying. Pass a naught and a1 are compared. That's all. Okay, this is the given array, example array given. So how many elements? N equal to 1, 2, 3, 4, 5, 6, 7, 8. So N is 8. Okay. So first pass number 1. So in pass number 1, we have how many steps? 1, 2, 3, 4, 5, 6, 7. So you have 7 steps in pass number 1. So how many passes you will have? Pass 7. Okay, so number of passes 7 because n minus 1 I told. N minus 1. So what you are doing? You are going to compare 30 and 50, 30 and 52. Okay, when you compare, no swapping is done. then I have to check what? I have to take 52. So if it is okay, if 30 is lesser than 52, okay, no need of swapping. Then I have to take the next index. Okay, a of 1, 52 is compared with the 29. If okay, we have to swap it. So what happens? The 29 comes here in the step 2. Sorry, here 29 comma 52. So like this we will do. Keep on checking the elements. At last what happens? 87 comes to the last index, highest index of the array. Why? Because this is 87 is the what? Highest element in the array. So automatically the 87 come to the end of the highest end of the array at the end of the first pass. Okay, like that. Next what happens? Next highest element is what? 30, 52, 63. 60 is the next highest what element in this array. So automatically in the end of the pass 2, what happens? 63 will come to the second highest. Okay, so this is the second highest index, so it comes automatically here. 63 comes here. Okay, fine. I'm going for the pass 3. When I'm going to pass 3, this is the output of the what? This is the once again. This is the output of the pass number 2. One second, pointer is not working. So at the end of pass 2, we have this is the output. This is the output. I can segregate this. I can divide this. Because this is what? Sorted array, and this is unsorted array. So I have to perform the pass 3 in this unsorted only. That's all. So automatically the 54 has to come this side only. So it is in the particular position. We'll see. So at the end of pass 3, what happens? Compare 52 with 54. Since 54 is lesser than 54, what happens? No swapping is done. So this is the actual output of the pass 3. So like that it happens. Okay, so like that it goes on. The highest element will move to the right side of the array. So next we'll move to the step number pass number 7. So pass number 7, what happens? We have to check only the 2 elements. We know at last n minus 1th pass. N minus 1th pass nothing but 7th pass here in case of this one. Okay, so in case of this one, we have to check the a of 0 and a of 1. So there is no swapping. The entire list is sorted now. That's all. So this is the sorted array. You can write like that. Fine. Next, algorithm. How we are going to write algorithm for this bubble sort? So here what you have to do, we can get two information from this analysis. One is, in the number of input is n, we are going to perform n minus 1 pass. So this is one information we got it. So we are going to perform n minus 1 information. Sorry, n minus 1 passes. So I have to take, when in single pass, I will perform number of steps. That is one information. Okay, with this information you are going to write the algorithm. So this is for number of passes. First for is for number of passes. For the first pass, okay, how many number of steps I have to do? This many steps. For the pass 1, I have to perform, I have inner for loop. First for loop is for pass, number of passes. Second for loop is for number of steps. That's all. Simple. Why we are writing here n minus 1, you know. Okay, the number of passes is n minus 1. And why we are writing here n minus 1? What is the reason here? Because automatically when the passes, number of passes increases, 3, 4 it goes on, automatically the number of steps also what decreasing, right? It told the unsorted array automatically is decreasing. That's why we wrote j to n minus 1. Get? So for example, for 1 equal to, when the pass is 1, pass equal to 1, it goes inside. Okay, so what happens? It checks for 1 to n minus 1. Because in the first pass I have to check for what? I have to do as many steps. Now as like the number of elements, right? Number of elements is equal to the number of steps I have to perform in the first pass. That's why I'm writing here like this, n minus 1. Then it goes inside. I'll check for swapping concept. This is a swapping function. You know about swapping very well. Okay, we have to take some temporary variable and we'll do the swapping. Okay. Here n minus 1. Here it is j equal to n minus 1. N minus 1 only. Okay. So what we have, so once it is sorted, now at the end of the first pass, what happens? This inner loop will be over. This inner loop will gets completed. Okay. At the end of the first pass, this inner loop gets completed. Then automatically the for loop increases. Index is 2 for n equal to, for I equal, for example, we'll take I equal to, earlier it was 1, now it becomes 2. For the pass 2, it goes inside again. Okay, it automatically performs. So the number of what steps decreases. Okay, so at last it exits the algorithm. So what is the complexity here? We have seen about the binary search tree, complexity, and binary tree and AVL tree. What is in that? The worst case, when you say complexity, will indirectly represent the time complexity only. I told clearly about the time complexity. Okay, and in time complexity, we have to tell the worst case of the what algorithm. At most case, what, how much time it may take to execute the what, to sort the element. For the bubble sort, so what happens? Clearly this function indicates. So this is a function. This is one function. This is a function. The algorithm is nothing but the function. Equal to first pass it have what is doing n minus 1. Okay, and the second pass automatically what happens? It is decreasing. No, n minus 2. It keeps on going. N minus 3, like that keeps on going. At last pass, you will check what only, you will do only one step. So it's equal to n into n minus 1 by 2. So finally it gets what? It is order of n square. I put as n2, it is n square. Okay, the complexity of bubble sort algorithm is order of n square, or order nothing but here big O. It is big O, nothing but the worst case. It means the time required to execute bubble sort is proportional to n square. Okay, when I give what, 5 elements, it takes 5 square time, 25 some unit, 25 seconds to execute the bubble sort. This is the complexity of the bubble sort. Okay, next we will come to the programming. How we are going to write program for this. Simple. We have seen two for loop, right? The same thing we are going to write here. The same thing we are going to write. Why this for loop is what? To get the input. No need to tell about more about this. Okay, we have two header files, main function, temporary variables are declared to swap the variables. Okay, so the maximum sizes we had decided is 10. Enter the number of elements. So we are getting some number of elements, 5, 10, 5, 8, 9, something else put. So this is for scanning to get the input from the user. It is, we are getting the input, it's not predefined, we are getting user input from the user. Okay, so here's the algorithm. This is first for loop, this is second for loop. That's all, simple. So why we told I equal to 0, we didn't write here n minus 1. Why? Because the array is starting from 0. Okay, the pass is starting from 0. If we put 1, we can write I lesser than n minus 1. Okay, got it? There's no difficult in this. Why I didn't put n minus 1? Because here we are starting the first pass, we consider the first pass as 0th pass. First pass as 0th pass. That's why we are putting simply n. So these are the number of passes. Okay, and it comes into the inner for loop. When I equal to 0, what happens? 0 lesser than n. N is what? N is what here? 5. For example, n is 5 elements. N is 5. So 5 minus 0 minus 1. Okay, 5 minus 0 minus 1. So what happens? 4. It is 4. So this, it will run for 4 steps. That's all. This first, for a first pass, the comparison is 4 comparisons will be done. Okay, so inside we are checking if condition. With why we are doing for this? For swapping. Okay, so if it is greater than, you will do all this performance using the temporary variable. You are doing the what? Swapping. Okay, so like this, it what arranges the element in the ascending order. Okay, we are performing for the ascending order. So if it is greater, why? How we say if it is greater, what you are doing? Doing some swapping. That's why we come to know that this kind of ascending order is this one. Why this for loop? For printing the elements, printing the already sorted elements. So the next type of sorting is the selection sort. Selection sort is a sorting algorithm that has a quadratic runtime complexity of big O of n square only. This is also n square only. Sorry, it's not n2, it is n square. It is n square. So as like bubble sort, this selection algorithm also worst case time complexity is big O of n square. It takes quadratic time. Inefficient to be used on large list. So it has some disadvantage of using large list. For due to some performance advantages, okay, for very large objects, for very number of large records with the small key, the smaller number of key, this algorithm will be useful. When they ask about application, okay, you can tell about this selection sort. Like very large record with the small key, the size of the key is very small, we can go for this kind of sorting. Okay, still students are coming. Example of selection sort. Okay, again you have several number of passes in case of selection sort also. This is an example for selection first pass. I give an example, single pass I given. Okay, in this selection, what I will do, so for the first pass, the first element is taken and is checked with the contiguous elements in the array. When a contiguous element is checked, okay, that's what the steps are shown. When I am checking the element which is lesser in the least element in the array, will come to automatically comes to the zeroth index. That's what the last step shows. This is the last step. The last step. Automatically, what we come to know that the lowest element in the array will be placed in the zeroth index. Once I place, this is the output of the first pass, and this is the input for the second pass. In the second pass, what will I do? I will sort only. I will sort only this elements only. These 4 elements only in the second pass. I no need to check for this first element, first index. Why? Because it is sorted. The lowest element is placed in the least. The least index of the array, zeroth index. So I have to check only the passes. The rightmost array. So from the again in the second pass, what happens? Automatically the number of steps decreases. How it is decreasing? Based upon the number of elements to be sorted. Number of elements to be sorted, it automatically the steps decreases when the number of passes increases. When the passes increase, automatically the steps in the pass will be decreased. The same thing, the technique. So in pass 1, find the position. That position is called as POS of the smallest value in the array. Okay, so one thing is that we are going to find the position of the smallest element. So previous slide we have seen what 0 is the smallest value, right? And we have to find the position of that smallest value. Once I find the smallest value, then I will replace in the 0th index. That's all. Then I swap that position value into the array of 0. That's all. I simply will check for the least element. Then I will swap particular position with the 0th position. That's all. That's what this says. And in the pass 2, what happens? Find the position of the smallest value in the subarray. Subarray n minus 1 elements. Subarray of n minus 1 element. So n minus 1 element is what here? These are the n minus elements. 1, 2, 3, 4, 5, 6 elements. Sorry, 4. 1, 2, 3, 5 elements. N minus 1. 5 elements in this array. So I have to check for what? In case of pass 2, subarrays represent this one. Subarray is representing this one only. Swap array of position with array of 1. Why? Because what? In case of pass 2, I have to place the least element. Here, what is the least element? 1. So 1 should be placed here, and 9 should come here. Okay, so 9 should automatically comes to the last position, and the second least element will come to the first index. And in case of pass n minus 1, so at last pass, find the position of the smaller element array n minus 2. What is this array n minus 2 and array n minus 1? Actually, at the last pass, what happens? I have to check only these 2 elements only. I check for only these 2 elements. That's what is saying. This one, how will you say? Array of n minus 1. This one, array of n minus 2.